Chapter 11, Section 1, Parametric Functions. On page 541, Exercise 2, x equals radical t minus 2, y equals t plus 5 over 4, and t is between 3 and 11. What we mean by parametric functions is like this. X is a function of t, and y is also a function of t. It says to sketch the parametric functions, t is called the parameter. We need three columns. We need t column, t values. That'll start, the t will start at 3 and go to 11. When we plug numbers in for t, we can figure out x using this, and we can calculate y using that. So 3 to 11. So we could list 3, 4, 5, 6, 7 all the way to 11, but we're going to just use 3, 6, and 11 because these are t values that will make the inside the radical a perfect square. Like 3 minus 2 is 1, and the square root of 1 is 1. 6 minus 2 is 4. The square root of 4 is exactly 2. 11 minus 2 is 9. The square root of 9 is 3. You could use other numbers. They have to be between 3 and 11. But you'll see these will be enough to get what we want. When t is 3, we go over here. 3 plus 5 over 4 is 2. When t is 6, 6 plus 5 is 11. 11 over 4 is 2 3/4. And t is 11. 11 plus 5 is 16 over 4. Which is 4. So when we plot the graph, to sketch the parametric curve, we only have a y-axis and x-axis. There's no t needed over here. We're just going to plot these points. Point 1, 2. Point 2, 2 3/4. And the point 3, 4. And this does not continue forever. It just has a starting point, which is 1, 2, and an ending point, which is 3, 4. That is called the parametric curve. X is a function of t. T could be time, and y is a function of t. Okay, so also we would like to note that this curve right here is a function according to the vertical line test. This graph, y, is a function of x. I can tell by the vertical line test. And it says to remove the parameter. That can be accomplished by taking the given equation, x equals radical t minus 2. We're going to solve it for t. Solve for t, whatever t equals, we're going to plug in there. So solve for t. Square both sides. Add 2 to both sides. And in the other equation, y equals t plus 5 over 4, we're going to replace the t with what t equals. plus 2. There's t plus 5 over 4. So y equals x squared plus 7 over 4 answers the question. Find an equation that relates x and y directly. So reread the directions. It says sketch the parametric curve. There's our sketch. Identify those which define y as a function of x. So y is a function of x according to the vertical line. And the last thing, eliminate the parameter. We find an equation that relates x and y directly. And do all of those things with exercise 4. Exercise 4, same direction. X equals a function of t. X equals sine t. Y is a function of t. Y equals t cosine t. And t is between 0 and 5. T, maybe you can think of it as time, is between 0, maybe that's second, and 5. So we make a t column where t goes from 0 to 5. You can get from 0 to 5 any way you want. So you just use the t values. 0, 5, or 2, and 5. Need more numbers than this. They all have to be between 0 and 5. When t is 0, x using that is 0. When t is pi over 2, x is 0. When t is pi, x is 0. When t is 0, y is 2. This is from 0 to 1. When t is pi over 2, y is 0. When t is pi, cosine of pi is negative 1. And times the cosine of pi is negative 2. To plot the parametric curve, you just plot these points. You plot the point 0, 2. 1, 0, and the point 0, negative 2. First point where t is 0 is here, and then 1, 0 came next, and then 0, negative 2 is 1. It's just this. There's no continuation because we can only use t values between 0 and 5. If we use other numbers besides these 3, but still between 0 and 5, we would just pick other points along this curve. And we can see that this parametric curve, y is not a function of x. It's a curve, but y is not a function of x, according to the vertical line. So all we have left to do is eliminate the parameter to find an equation that relates x and y directly. And this can be done with trigonometry. Suppose we have a right triangle. We know that the sine of t is equal to x. It's given. And this angle right here is angle t. We can put an x here and a 1 here because sine is opposite of an hypotenuse. Sine of t, here's angle t, is opposite of an hypotenuse. This horizontal side squared plus this vertical side squared is equal to hypotenuse squared. So the question mark squared equals 1 minus x squared. And the exact side of the triangle is the square root of 1 minus x squared. The other equation, y equals 2 cosine t, cosine t can be replaced with adjacent over hypotenuse. Cosine t means the cosine difference. Cosine is adjacent to hypotenuse. And down the 2 and the y equals. So we have y equals 2 radical 1 minus x squared, which can be written many other ways. Like you can square both sides of the You can distribute the 4. So I'm going to give this as my answer. Y squared equals 4 minus 4x squared is an equation that relates x and y directly. Parameter eliminated. There's no t at all. Here's the parameter. This, by the way, is the equation of the ellipse. Where this curve is one side of the ellipse. All ellipses are one is number 18. X equals t squared plus 2t. X is a function of t. And y equals t squared minus 2t plus 3. And t is between -2 and 3. First thing it says to do is sketch the curve using t values from -2 to 3. So you're going to start at -2 and go to 3. We're going to use these t's to figure out x using this. We're going to calculate y using -2 in here, for x in here. -2 is 0. Put -1 in here, -1, plus 0 in, -0. X is 1, x is 3, x is 2, x is 8, and x is 3, x is 15. Since t is -2y, using this y equals y is 11. Since t is -1, y is 6. And t is 0, y is 3. And t is 1, y is 2. And t is 2, y is 3. And t is 3, y is 6. Just plugging the t's values from -2 to 3. This is what x equals and what y equals. But when we sketch the parametric curve, we only sketch the points with those x and y coordinates. Okay, so now the order these plotted in can be important. So we're going to plot the point. The first point is 0, 11, which is going to be off this chart here. Right about there. Then we go to -1, 6. So we went from that red dot up there to that one. Then we go to 0, 3. Then to 3, 2. Then to 8, 3. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. And then finally, it's 15.6. Which would be roughly there. So we indicate the direction in which this goes, that this is the starting point. And then we went in this direction to there, to there, to there, and we stop there. So there's nothing after this point. There's nothing before this point. But we show arrows to show where we show the direction we traveled. So there is the answer to part A. And then 18 also asks us to find the leftmost point. On this parametric curve, there's a leftmost point. And finding the leftmost point means, since the x is what goes left and right here, left and right, x-axis, finding the leftmost point is the same as asking us to minimize, and the smallest, minimize x. If it asks for the rightmost point, we would maximize x. The small x's are to the left, bigger x's are to the right. So this is important to know how to minimize anything. To minimize x, which is t squared plus 2t, we find x prime, which is 2t plus 2. We find when that's equal to 0, which is when t is negative 1. And the answer is going to be the minimum x is when t is negative 1. The minimum x is when t is negative 1. And we already see in our chart that when t is negative 1, we're at the point negative 1, 6. And that is the leftmost point. When t is negative 1, x happens to also be negative 1. And y happens to be 6. So negative 1, 6 is the leftmost point. In other words, it's the point that has the smallest x coordinate in this red curve. Part C says to justify this. And here's how we justify on the AP Calculus exam. Justify that something is a minimum by doing this. We have x, which is the thing we want to be the smallest, x prime, and t. On this t line, we mark negative 1 and indicate that we're marking that important point because that t value makes x prime 0. X prime is 0 when t is negative 1. Plug a number to the left of negative 1 into x prime. For example, plug in negative 2. Let's see, x prime is negative. Plug a number bigger than negative 1 into x prime. Say you plugged in 0 into x prime comes out positive. When the derivative of something is negative, when the derivative of x is negative, that means x is decreasing. When the derivative of x is positive, it means x is increasing. So please write this on an exam. X prime changes from negative to positive at x equals negative 1. So x is minimum when t is negative 1. So I made a mistake here. This should say t also. X prime changes from negative to positive when t, this is t, get rid of this, is negative 1. So x, which is up here, is minimum when t is negative 1. So this just justifies the answer that we gave over here. It's these words that justify. The picture helps me write the words. I have to write the words. All right, we're going to do one more. I'm doing number 20. X equals tan t, and y equals secant t. And t is between negative 1 and 1. T is between negative 1 and 1. To sketch the curve, we'll make a column of t values that start at negative 1 and go up to 1. Calculate x using this. When x is negative 1, when t is negative 1, x would be the tangent of negative 1, which is about 1.557. When t is 0, x is 0. When t is 1, x is the tangent of 1, which is approximately 1.557. And actually this number up here is supposed to be negative 1.557. Of course you get these from a calculator in radian mode. When t is negative 1, y is the secant of negative 1. Find on a calculator by pressing 1 over cosine negative 1. You get about 3.702. And this is positive 3.702. When t is 0, y is this. Actually copied this wrong because there's supposed to be 2 in front of this. When t is 0, the secant of 0 is actually 1, so y is instead of 2. And when t is 1, y is 2 times the secant of 1. On the calculator, that would be 2 over the cosine of 1, which is 3.702. And there's no mistakes anymore. These are both positive y values. These are all positive y values. You use t's to get the x's and the y's, but sketching the graph, you just use the x's and the y's. Use the t. So left 1.557, up 3.702, 0, 2, and 1, 3.702. Points start here, go to there. There's no points after this or before this one. That's the parametric curve. It says identify the lowest point. The lowest point would mean, to find the lowest point means to minimize the y. The y axis goes up and down. If I want the lowest point on this, it means I want the smallest y. To minimize y, we need y equals secant x. Y equals 2 secant x. We need the derivative of y, or y prime, which is 2 secant x tangent x. We need to know when the derivative is 0. which would have to be when tan x equals 0, because this could never be 0. Secant x is never 0, because secant is 1 over cosine. There's no way that can be 0. So 2 secant x, tan x equals 0 only when tan x equals 0. And since the tangent of 0 is 0, and you have to change all these x's to t's. Learn from mistakes. These are mistakes. But it's really important. These are not x's, these are t's. So we need 2 secant t tan t equals 0. 1 over cosine t, or secant t, is never 0. The derivative of this can only equal 0 if tan t is 0. And since the tangent of 0 is 0, we're going to get the lowest point when t is 0. And when t is 0, we're at the point 0, 2. So the lowest point on this is the point 0, 2. The justification goes like this. This is where we get the points for justifying the answer, not just for saying that it's 0, 2. We're trying to show that we found the lowest point, which means we found the minimum y. On this t line, we mark 0. The absolute y prime is 0. Plug a number smaller than 0 into y prime. That means plug a number smaller than 0 into this. And you'll see that you get a negative. Plugging a number bigger than 0 into y prime, you get a positive. So this is evidence that y decreases. This is evidence that y increases. Minimum. Y is minimum. In other words, the curve is at its lowest point when t equals 0, because y prime changes from positive